Now, the relation between user threads and kernel threads. Most of the time, we use thread libraries. Like in assignment number 2, we will be using a library that implements the POSIX standard, POSIX threads. That's what we will be using in assignment number 2. There are other libraries like Windows threads and Java threads. We will be using POSIX. Now, these thread libraries allow the user to define threads. But how does the mapping, how do these libraries do the mapping between user-level threads and kernel-level threads? Now, most modern operating systems support threads at the kernel level. So the mapping between user-level threads and kernel threads can be done in a many-to-one or one-to-one or many-to-many. What does this mean? So many-to-one means you map all user threads into one kernel thread, which is something that only older systems used to do. So modern systems do not do this. Because it's not giving you true parallelism. So all the user-level threads are mapped into one kernel thread, which means you're not actually having parallelism. And if one thread blocks, it's going to kill other threads. It's going to block all other threads. So some of the older systems used to do this, but modern systems do one-to-one. Like Windows, Linux, and newer versions of Solaris do one-to-one. So they just map each user-level thread into a kernel-level thread. And in this case, you have all the parallelism that you want. So it's maximum parallelism. But the problem is that it's not setting a limit on the number of kernel-level threads. Usually we want to minimize or we want to limit the number of kernel-level threads because there is an overhead, system overhead when a process has too many threads within it. So in order to limit the number of kernel-level threads, we may map an arbitrary number of user-level threads into a fixed or limited number of kernel-level threads. So in this example, I have 4 user-level threads that are mapped into 3 kernel-level threads. So this will try to achieve a balance between many-to-one and many-to-many. So you're still getting some parallelism, some true parallelism here. Parallelism or concurrency, assuming that you have 3 cores, this will be true parallelism. If you don't have 3 cores, then it will be only concurrency. But you have this parallelism or concurrency, but it's limited. So you are limiting the number of threads to limit the overhead of thread creation and maintenance. Another model is a 2-level model in which we have the many-to-many model. So we have many user-level threads mapped into many kernel-level threads, but some user-level threads may be mapped to their own kernel-level threads. So this is this is another scheme for trying to achieve or to get the advantages of both schemes. Okay. So now we will talk about thread libraries. We already mentioned that there are multiple thread libraries. In our assignments, we will be using POSIX, a library that implements POSIX threads, because POSIX is a standard. It's not a library. We will be using a library that implements POSIX, and it will allow you to create threads. We have the concept of asynchronous threading and synchronous threading. And asynchronous means the parent thread and the child thread or threads are running in parallel, while synchronous, the parent thread is going to wait for the child thread. Now in the assignment, we will be doing asynchronous and synchronous. So we'll have a parent that will create multiple threads that will be running in parallel, but we'll do some synchronization. So it will be synchronous in the sense that the parent will, at the end, will be waiting for all the child threads, because the parent will look at all thread results, and it will print the final result based on the results of the multiple threads. So this is very high level, very vague, I know. But when we get to the details of assignment number 2, this will make more sense when we actually describe the problem that we will be doing in assignment number 2. Yeah, so the POSIX is just a specification. It's not, it's not a library. There are multiple libraries that implement it, or on each system there is a different implementation of the same standard. And it's implemented on many Unix operating systems.